Rendering is where it all comes down to. Weeks, months, or even years of working on a few seconds of footage, then potentially take up to 100 hours of render time for each frame. For reference, the 10-second long shot we are working on now took over 24 hours to render. Lighting and rendering go hand in hand, so we will work accordingly. Accurate, or at least a well-set-up lighting, is what sells the shot. That is what brings not only realism to the scene, but all the emotions and life as well. This is why a Pixar film such as Soul looks so full of life, despite being a fully animated film. Rendering itself is all about balancing time and quality. Low render settings will result in a noisy image, but high render settings will cause render time to increase. The trick is finding the best quality you can get in the shortest amount of time. Another noteworthy thing is that we don't render the final image. We render many layers and image planes as well as we can. Then we composite those together into the final image later. As I will insert the render into a real-life location, I had to prepare a few things first. For correct lighting and light reflections, I had to take a spherical image of the location and a picture of just the ground itself. I will use these to light our scene. I also needed a color checker and a kettle because it is a similar material to Mjolnir, so it is a good reference guide. I started by removing myself and the kettle from the 360 image. Then I sort of turned it into a HDRI. It stands for High Dynamic Range Image, and it is supposed to be a blend of multiple images with different exposures, giving us a really wide dynamic range. But because I couldn't do that, I saved this image with different exposures instead, and blended those together. It's not the best, but a little bit better than nothing. Now back to Houdini. As you may recall, we only textured the outside of the hammer, which means that the inside has nothing applied to it. So first, I separate the inside and the outside and assign different shaders to them. Then similarly to how I did in Maya, I brought in the textures, then went back to Substance Painter to create the inside material. The next step was setting up the HDRI, and because it was daylight, also adding a sunlight to the scene to make it a bit better. The ground deserves a nice shader too, but because we won't actually render it, and I only need it for the reflections, I just applied the image I took of the asphalt. I set the camera's focal length to match my phone's and dropped down the background image as an image plane. And now I could more or less orient the camera. And here comes the color checker. Because I have both a digital and a physical version of the same colors, I have a good reference point to help me set up the same lighting conditions in the CG scene. Now, I actually spend the time to line up the shot, testing and tweaking to get as close as possible. As you can see, this is most of what setting up lights and renders is about. The thing is, you don't really see what you are doing until you test it, so you just go back and forth a million times improving things step by step. I ran a quick flipbook to see if the hammer would touch the ground correctly, and I was kind of happy with the result, so I moved on to the lightning. As lightning is its own light source, we have to make sure that our lightning geometry knows that it's supposed to emit light. Now you might think we are all done. But as I said before, we don't render final images, we render layers and image planes so we can nicely composite them together later. To make things simple for now, there are 3 parts to our scene: the hammer, the lightning, and the ground. Yes, the ground too. Even though we will use the image I took as the background, we still need to add the correct shadow and light reflection onto that, so that the CG element would affect the real-life image. This is where the kettle comes in handy again, and I can use its shadow as reference. So the first render layer is Mjolnir, and now that it's pretty much good, I added the displacement map, which would have just slowed down the test renders earlier. I also turned the lightning and ground into phantom mode, meaning that only the light being emitted or reflected from these objects will be visible in the render. The actual objects won't be. This way, I have the hammer nicely isolated with the correct lights. Now I could select a small area to render and make sure to increase my lightning light samples to reduce noise as much as possible. Then again, these will only show up for a few frames each time, so no need to worry too much. Let's move on to the lighting. Don't ask me why it is upside down. It just is. It's one of those things you have to learn to live with in this job. Here, I turned the ground phantom and Mjolnir matte. Matte is similar to phantom, except that where the object should be, you essentially have a hole in the picture. Remember when I talked about masks in the texturing video? It's similar to that like that, but here it's called an alpha channel. Finally comes the ground, and again, no idea why it is upside down. Here, you can better see how there is a black cutout where the hammer should be. This can also allow us to save render time. If I know something won't be visible, I don't need to waste time rendering it. The lightning geometry was casting a shadow on the floor, so I fixed that, then rendered all the layers. With the images rendered, I brought everything together in Nuke. This is the raw render, ready to be composited together to create the final shot. And that is what we will do in the next video, where we will combine all of our layers together and add the final touches to create a realistic footage.